All right, hello and welcome everyone to GLOBEBUSTERS Season 14, Episode 12. Today we're going to be getting into the history of wave invariance, but before we do that, let me introduce the panel. I'm joined today by Shane G. How are you, Shane?
What's up, everyone? Good to be back another Sunday.
It's good to be here. I agree. Missed you guys. And Stone G down there, I see you. How are you,
Yeah, hey
sir?
everybody. Good to be kicking it back in gear. That's for sure. Oh, busy around here, man. Just insane. But glad we can take the time.
Dude, did I read there was going to be an upgrade to the ManofStone Telegram channel? A little scheduled
Well,
voice chatting, perhaps, or something
you
going
did
on?
read that. That's cool. Yeah, because I just typed that about an hour ago. Yeah, it's just a little continuation, I think, of what was happening a week ago Friday night on Brian Sweet's Spaces. We ended it up that night talking at length for about a half an hour to a skeptic about a resource-based economy paradigm and how just getting the human populace to recognize that it is an option to discard the monetary system and the monetary sequence of value, for that matter, altogether, for the dinosaur that it is, along with political representation and a few other enslavement device paradigms that have been inflicted upon us as a species. So yeah, that's going to be a Sunday night thing, I think, if we get enough people interested who want to show up and talk about it and even take away things to do week to week so that we can get a better grip on where we stand as a species. It's pretty cool.
Awesome. Well, if you're interested in finance, there will be a link in the chat here in a couple minutes for the for Stone's Telegram. So, oh, bless you, Shane.
Yeah,
That's a
should
good
I
one.
call an ambulance or something? You okay there? Holy moly.
No, it's all good. All right,
It's good
so
to hear. It was
this,
5 in a row, so it was a big one.
so I'll go ahead and get the screen share up here. And Shane, I moved everything to Canva, so it'll look nice and big.
I'll tell you that the first time I watched this, I saw some highlighting, and I was like, "Did Kat do all your highlighting, or did you suddenly learn how to highlight only one color and only the
No,
important stuff?"
no, I bring her in to highlight stuff. I
I
save a
didn't,
bunch of
I didn't
stuff.
want to interrupt the presentation last time, but I wanted to know: is this real highlighting, or did you fake us all out with someone else doing all your highlighting?
No, I outsourced it to Kat. All right, so this is the history of wave invariance. We're going to learn about some equations that are used to describe relative motion with respect to a medium. And they were, in the way that it's modernly interpreted, there's no medium. So instead of having a stationary reference frame for the wave frequency and wavelengths to be relative to, they say that it's just relative to an arbitrary stationary reference frame upon transformation because everything is in uniform rectilinear motion, which defines it as an inertial frame for them. And they say that because of this, you can't measure absolute velocity because of link contraction and time dilation when you're going at, quote unquote relativistic speeds. But what they mean by that, the introduction of the theory was originally to explain the difference in cosmological speeds, which don't even fit the parameters for relativity theory to invoke the amount of link contraction and time dilation to justify anything like that. But anyway, we'll go back to the history of these equations and we'll see that there's another interpretation from whence they were all derived and a direct equivalence to an ether theory and ether mechanics rather than empty nothingness quantum fluctuation mechanics. So here we go. We're going to be taking a look at C plus or minus V in particular. Now, in modern terms, they describe uh, the V over C ratio as V squared over C squared, and they wrap that up in the relativistic paradigm in terms of link contraction and time dilation. But when you realize the framework in which everything was once derived, you'll understand that when they talk about link contraction and time dilation, all they're talking about is something exceeded the speed of light or it was measured just under the speed of light because it basically traveled a distance or existed longer than what they would predict the half-life would be, And in order to do that, it would have to be traveling at superluminal speeds. But in their paradigm, they interpret superluminal speeds as link contraction and time dilation via the exact same equations that describe dilation and contraction of the wave and frequency itself, rather than actual individual pockets of time that are not that are localized to individual phenomenon and have no meaningful connection to anything around them, which is what the interpretation of the same math is if you remove the significance of the medium and make the transformation with respect to some other moving object. So a big shout out to It's BS. Let me make sure I got the screen share going right. Looking good, looking good.
Yep, we're seeing.
All right, awesome. Just double checking. All right, so big shout out to the YouTube channel It's BS. He's a great resource for understanding relativity theory and some very simple and straightforward debunks that only require the understanding of basic algebra, because that's what the backbone of the theory is. It's just algebraic transformations, essentially. So nothing super fancy. So as long as you're familiar with solving for X, you can totally understand relativity, like the way that it's been mystified, and all that is just to make it seem like it's more than what it is, because it's literally just stealing ether equations and relative velocity equations. So all right, so this is the last look at Einstein here. He's like, hey, I got this theory here that says length and time contract as a function of velocity. It's definitely not c plus or minus v, but it's been c plus or minus v the whole time, guys. So that's what we're going to get into. So the first time that we see c plus or minus v used is as a ratio for stellar aberration when it was measured by James Bradley. Now, granting everything in the model, aberration doesn't prove anything one way or another. It's a kinematic measurement on its own. Just aberration in air is just kinematics, so it could imply a velocity of Earth at 30 kilometers a second based on that angle and the and ratioed over the speed of light, or it could imply the movement of a medium in between us and the stars that's moving at that rate, or it could imply the motion of the stars themselves and at that rate. And there's it's just the sidereal drift. So any one of these mechanisms, just based off of the measurement alone, is equally valid. You would have to introduce another manipulation of an independent variable there to determine whether or not the cause of motion is actually the Earth or if it's some other mechanism. Because if the starlight already comes in like that, then you would have a direct equivalence in air. So anyway, this discovery was pretty big for them because it was the first time that they ever got a measurement that corresponded to what they were ratioing out with Kepler's laws. Because if you do Kepler's laws, which is just ratioing pi over the periodicity of the sun, they interpret that as Earth completing an orbit. So that gives them a velocity component of 30 kilometers a second when they ratio that out. So this ratio of the stars with a V over C here was their first significant interpretation of their model being correct. And also it uses, if we look at the math here, the simple V over C, what this implies is C as a inertial frame, as a stationary absolute frame. So it's using the absolute value of C as a constant. And what we'll see is C is not a constant in reality. It's a mathematical constant. It's, derived in that way as a function of electric and magnetic permeability properties, but it is not the limit of the speed of light. And that's a very important concept, because the speed of light will be measured plus or minus the velocity of the observer with respect to how fast the emitter and or observer are moving relative to one another, contrary to the way that relativity would like us to interpret it.
Dude, I guess you
What's
forgot to do the correction I sent you on this slide.
Which
Everybody
one was
looking
it?
at C, keeping the units the same here. Keep for the value of C, that second comma should become a decimal point. For the value of C, it's not 300 million kilometers per second.
Right.
It's 300
I'm sorry.
million meters per
Yes.
second.
Yes, I have
So the second
meters.
comma should be a decimal point, and everything else would still be correct.
Yep. Good catch. Sorry about that. Totally did forget. I have the meter value
Busy.
as kilometers.
It's a small thing, but it's a thing.
No, extremely important. But yeah, everything is ratioed in kilometers. So that should be, like you said, just put a decimal there and we're good to go at 200 at basically 300 million. So for the purposes of the Prezi here, we could just always, whenever we talk about c, or the speed of light, just conceptualize it as 300 million kilometers a second. It's easier to round it
Meters per second.
Meters per second.
It's like 300,000 kilometers per second. That's why we're putting the second column is going to be a decimal point.
Yeah,
that would make it 300,000 kilometers.
I've got meters
Now you're
stuck
in a loop,
dude. I've got meters stuck in my head from spreadsheeting. So I do everything in meters. Okay, sorry, you're right. Okay, so moving on, we have we have Arago, Francois Arago. In 1853, we're going to go through the timeline of the use of the V over C relationship to substantiate their cosmology, which is, of course, based on fundamentally the Copernican principle, or the cosmological principle, as they say now, which just means that the Earth holds no significant place in the universe. And the only way to do that, to have that position, is to have the Earth be in motion. And so this philosophical interpretation of mixing physics and math ratios with the motion of the heavenly bodies is huge for them, because they have a they have a physical interpretation of the celestial bodies rather than appreciating their heavenly beauty, and not an understanding that they don't truly know what they are, but everything is based on them knowing what they are. That's why astronomy is the highest level of like it supersedes physics in terms of hierarchy, because everything comes down from the interpretation of what's going on with the stars. When you look into geophysics, the first 5 chapters of any geophysics book is, hey, when we look at the stars, we know that they're burning cores and they're spinning and all. So therefore the Earth must, like they do the whole thing based off of all of that. So merging these two with ratios and math is extremely important for them, because it gives them credence to their physical interpretation of everything. So they begin to do experiments to substantiate that velocity, because like I said, it's just that the measurement itself in air is just kinematics. So in order to substantiate it, they would need to manipulate one of the independent variables there. So here they manipulate the refraction index, and they the premise of this was that they would half cover this telescope with a crystal prism. The starlight would be coming in at the center, and as it hits the center and intersects with that crystal prism, the light slows down, and the angle would increase, because the Earth would move further out from underneath from the time it takes the star to traverse the telescope to the eyepiece. Sounds a bit ridiculous, but they will later go on to do experiments to verify and substantiate how much velocity affects angle and all that with respect to the refractive index and everything. So they did have some rational reasoning behind what they were putting forward with this in their interpretation. But here they measured no angle deviation, and what this implies is that the starlight already comes in at an angle and the Earth is stationary. And their interpretation of this was that the refraction index of a moving prism is the same as a stationary prism, which is a very generous interpretation of the results there. So to keep their belief system alive, they started coming up with hypotheses to explain how maybe there's some sort of ether drag effect, where there's ether inside of the telescope and it's bouncing around and it's carrying the light in the opposite direction. So they started proposing this as an idea to still substantiate their belief system in motion and the concepts for ether, which they were using to explain electromagnetic propagation. So in 1818, so keep in mind this was in 1853 there. So I think I'm slightly out of line on my timeline, because we're going to go.
No, actually, it's an overarching theme to this presentation that I'm feeling, that I think the audience should also pick up on, is that this is how long the Globies have been trying so hard to get some kind of experimental proof that we're actually in motion. You know what I mean? But
True.
This is how long the Globies have been trying to perpetuate this myth and use mainstream to do it.
So true. And this is a truncated list of stuff because there's even like more experiments they did in between, but I'm like covering the big ones here. But yeah, they've been trying to substantiate that velocity, and every time they do an actual experiment, anytime they manipulate an independent variable, that velocity is gone is gone. They never get it again, which is crazy. Because the only implication is if you add a medium to that and it's the same, is that the Earth is stationary and the light already comes in that way. And the only way you could explain it is via mathematical transformation. And we'll get into some of the crazy mechanisms as we continue. But as we move forward here, we're going to cover the history of how they even derived, uh, like how much velocity drag there should be in a refractive medium and all that stuff. So in 1818, a man named Fresnel came up with a derivation for how much velocity would be translated to a moving medium based on the principles of an elastic ether, where the proportion where the ether inside of the translucent medium is proportional to the refractive index squared. So using that principle over here, he comes up with equation 11.3, which just says that the speed is equal to the speed of light over the refractive index plus or minus the velocity of the refractive index. So if it's going with or against the moving media, and then times 1 minus the 1 over the square of the refractive index there. So that's gonna, so basically the more the higher the refractive index, and the faster it's moving, the more it's going to be dragged, the less refractive it is. Even if it's moving faster, it's still going to drag less because it's small. These come out to be very small proportions. So all right, so anyway, we can see though that the principles in which they were derived are with respect to an elastic medium. And if you note how the speed of a wave in a medium was derived, like for sound in particular, it's proportional to the square of the density of the elastic medium. Or yeah, so what you'll see here, continuing on when we get to electromagnetic propagation, it's going to be proportional to the inverse of the electric and magnetic vacuum properties. So these principles of a medium and densities and squares, proportional ratios, are all, fundamental properties of deriving how things are changing with respect to a medium. These are the principles in which they were deriving everything from. So here we have Doppler, who comes around in 1842, and he drops his paper on the principles of the Doppler effect. And basically he starts off by saying that there's that he's not convinced about the ether theories that explain motion in terms of light being dragged back and forth in such a way that it creates the illusion that there's no motion. And he gives the note of how sound works in air, and he gives his equations here, which represent C plus or minus V, is what it's going to come out to be. So all you need to do is have the speed of the wave in a medium, and so in most cases it's the speed of sound in air, or you could use the speed of light in a vacuum. Either one, these all produce the correct result based on the ratio to the motion. So so what he's showing here is that when he goes on to derive everything from his little manifesto there, he shows that that the change in the frequency of a wave as measured by an observer is measured relative to its original frequency as if there was no motion. So if you had like a baseline starting point where you measured a frequency between an emitter and observer when there was no relative motion between them two, you would hear or see the light in a certain way based on that frequency. And then if you were in relative motion to it, you're going to hear it at a higher or lower pitch based on the relative motion to the source and emitter. And that change in frequency that you hear it at is directly proportional to the velocity. So That's what these equations represent. And again, we're looking at C plus or minus V. And he goes on to show that these same exact equations, you don't have to add anything different or change anything in the formula. You just have to change the speed that you're using to the speed of light in a vacuum. And they describe the same frequency shifts based on the wavelength changes. And of course, around this time, they had begun categorizing wavelengths and frequencies as well. So they had a nice catalog of everything to break everything down for to understand these ratios, to apply them to these equations. So as we go on to look at Doppler shift, I kind of already explained it here, but if you're stationary and an object, let's say a car is moving towards you and it's playing its horn, you're going to hear a high pitch frequency because it's moving towards you, and that's going to be you're basically hearing the compression of the waves with respect to the medium as a function of the velocity of the emitter, and that's changing how you hear the wave fronts. So that's what we're going to be looking at here. So I went over the stationary comparison for frequencies. So where F equals F naught, that's going to be your stationary, unchanged wave source. So we see that the wave front is emitting symmetrically here. Nice, clean, equidistant emission. Very nice. And then we have a moving emitter here, and we see that the wave fronts begin to get compressed. And as described by the equations, the change in the frequency is going to be a ratio of the velocity with respect to the stationary wavelength and frequency. So moving on to supersonic speeds here, we describe how the information will be received with a delay. So the source emitter will pass a stationary observer before the sound of the source emitter is heard. So this is what this is describing. So this would be when something is going superluminal. Now, to kind of show those principles in use, they're used today with police radar and military radar. So the same principles of this frequency shift to measure relative motion and categorizing the change in wavelengths with respect to these ratios is actually how radar guns work. So very simple V over C ratios. Again, all you do is enter the frequency of the electromagnetic radiation. So anytime I say light or we go over light, that's going to be whatever frequency of electromagnetic radiation. It's just easier to say light there. So anyway, whatever frequency of light you're using is going to dictate your frequency, and the relative velocity ratios are going to be calculated as an output of that. Because what happens is the signal that gets sent back to the radar has a beat frequency to it, and that's a change in its frequency that is imposed on it with respect to being re-emitted from the velocity of the moving observer, so to speak. And then when you get that information back, that change is always going to be proportional to the velocity, like in a 1-to-1 linear relationship. So it doesn't matter like if the device is calibrated or whatever. All they need to know is what frequency was sent out when the measurement was made, and what they get back, whatever velocity they get back, is always going to be a ratio of that original wavelength to the exact wavelength. So that's a really interesting mechanic, and it's exactly how sonar works. So like they use a range measurement equation, which is based off of the speed of sound in a medium, which is water in the case of sonar. So when they use that equation to derive distances and velocities based off of timing on how fast that wave is propagating with respect to the medium and how fast the objects in the water are moving with respect to the medium, these are all wave mechanics with respect to a medium. So we're looking at the real-time practical application. They say that at these speeds, they're not measuring, relativity falls back to classical mechanics. So we're just looking at, we don't have to apply any Lorentz transformations or do any gamma factor corrections because the velocities are too slow. Well, if that's true, we're looking at a classic V over C, or, V over C, which means V plus or minus C relationship here, which means, which we're going to see the implication of that, how it plays out experimentally, because we're already starting to see that they got a ratio once that corresponded to what they believed in, and they've all this technology is based off of changes in frequencies with respect to original wavelengths and stuff. So they know with very precise precision. Uh, they know with a high degree of precision, what they should expect when they do an experiment with light and velocity. So we got some patents here, just kind of going over the technology, and the one that I thought was really cool was the one that derives distance even or velocity even if you're moving. So what it does is it sends out two signals. One's kind of angled towards the ground, a little sharper. So the signal that it gets back is going to be way stronger than the one that goes out at a distance and comes back. So they take the beat frequency from the one that gets reflected off of the ground, and that they subtract that velocity amount, because like once you have the beat frequency, you automatically have whatever the velocity is. So they subtract that out from the other reading of the weaker signal, and then that gives the velocity of whatever they're pursuing. So that's the basic principles of what they're putting forward. And that started all the way back in 1842, and nothing has changed. Same equations. All that's changed is that they've added a gamma order term, and we'll get into what exactly that means and who owns mutual exclusivity over the gamma term. But we'll continue on with our history of using the velocity of light and how they figured out how these ratios and relationships change. 1 second, I'm going to get some water.
Oh man, I was hoping you had updated this one with the color plan for those arrows. That would have been cool.
Yeah. Nah, wasn't able to do that.
I got you covered.
Nice. But based on those principles that we talked about earlier from Fresnel, who derived the speed of or how much the wavelengths would change with respect to going through a moving medium, and how much of the velocity of that medium would be translated to the frequency shift. We have Fizeau doing an experiment here with sunlight. So he comes up with a beam splitter. He's got he's got water going through a tube here at a known velocity, and they know the refraction index of water at this point. And so they enter all their necessary information, and they calculate how much the fringe shift should be, which means, in other words, if they're using a single light source and they're splitting the beam and it recombines, if there's no velocity translated between them, then when this beam recombines, there should be no fringe shift pattern, because the beam should still be in phase, but it's going to be slightly out of phase due to velocity. So when it recombines, it's actually going to be out of phase at a proportional ratio to the velocity traveling with and against. So in other words, the split frequency is going to be retarded a little bit, and it's going to be boosted a little bit, and the out of phase proportion of that when it hits the screen for the observer is going to create destructive interference, which creates this black fringe pattern here. And there's two ways you could measure this here. If you're capable of measuring the phase shift, which is actually a way to measure the physical wavelength between the light, that would tell you the change. Or you could do this, which 4 times that wavelength change is proportional to how much this black pattern here is going to be for the destructive interference, and then the distance of this black section here squared is proportional to the velocity that created it. So there's different ways that you could interpret that mathematically that serve the same purpose, because back in the day that they didn't have the technology to measure the actual wave front, or I'm sorry, the phase shift like that. So this ratio here is the way that they did it in terms of fringe patterns. So they established a ratio of fringe to velocity using the exact same principles of C plus or minus V, which means the speed of light with respect to a stationary medium, and then using that ratio change to predict what will happen. And then it turns out that dynamically in the real world, this creates an actual timing difference in the clockwise and counterclockwise propagation, which ends up being a real fringe shift pattern, which is proportional to the square of the velocity, which is crazy. So when we look at uh, the Michelson-Morley and INS systems and SAGNAC and stuff, we see that they do have the capability of measuring a velocity shift, but the way that they have to interpret it now, because they can't measure or have never measured the velocity required to substantiate heliocentrism, is needs to be hidden and obscured from the public through the guise of relativity theory, even though everything is going to be running on the backbone of classic physics, which has always been C plus or minus V. So here we have transverse Fresnel drag. So this wasn't measured at the time per se. This was done in the 70s, but this is an instance where the medium is moving transversely to the detector, and there should be no distance change with respect to the observer for transverse motion. When you're directly 90 degrees with respect to the motion, there's going to be there's no distance change. It comes from the deviations from that 90, where you're going to get the increases in frequency. So the classic theory would predict, the way that it's framed, they say that the classic theory predicts no transverse drag, and only the relativistic theory predicts transverse drag. But they don't call it transverse drag, they call it time dilation. But we're going to see some ether theories that do predict transverse drag to the half gamma factor, in fact, which is pretty awesome. So relativity actually ends up with no mutual exclusivity. But what we're going to find out here experimentally is that there should be transverse motion here translated to the frequency. So in this experimental setup here, we have a source emitting a frequency of light, and we have a rotating plastic disc. This disc can go clockwise or counterclockwise. It comes down here, hits two 45-degree angled mirrors, comes back up through the plastic disc, and goes through a detector. Now, because relativity theory uses the same equations but makes everything about relative motion, they actually predict that the light should change in two different directions based on going with or against the direction of motion as it's going through this and coming back out. So it would predict that there would be it would get velocity addition in one direction, and then it would get retarded in the other direction. But what actually happens is it's always positive in the same direction, no matter what direction this is going, clockwise or counterclockwise. And the only mechanism for that would be as if the motion is with respect to a medium. And we're going to see that the same exact equations that Einstein tries to use to describe time dilation to a really small factor is actually just a function of the change in wavelength with respect to velocity. Which is, of course, with respect to a medium. So as so we're looking at the results here and just talking about the change there and what relativity predicts versus what was measured. And he says that, irrespective of the rotation of the disk, it is proportional to the it's positive in the same direction, and it's always proportional to the square of the rotation speed. So that's extremely significant. And even moving at slow speeds, it's very easily readable. So very conclusive there in terms of the ability transverse motion and what ether theories predict, because again, the same equations that predict the longitudinal drag are being applied here for the derivation to predict the fringe there. Like there's not doing anything crazy. So everything there is just Sagnac with refraction index, and it's coming out exactly what we would predict. Now in 1862, we have Foucault measuring the angle change with respect to a rotating mirror with light coming through a medium. So the medium slows down the light going through the tube, which gives this rotating mirror more time to change position angularly. And that change in position is going to affect the angle in which it's reflected back as a function of the velocity of the rotation rate of the mirror itself. So this is a really important experiment because this falsified the emission theory completely, because the math for the emission theory basically predicted, instead of dividing by the refractive index, they were multiplying by it. So they predicted that when light hit the refractive index, that it would accelerate in the tube, and then the angle that gets measured, it ends up being a smaller angle. So it's a reduction in angle. And the undulatory theory, which meant the wave mechanic theory at the time, which was waves with respect to a medium, that theory predicted that the wave would slow down in the medium and more velocity would be translated to the angle change. So it predicted an increase, and that exact increased ratio was measured. So the undulatory theory was shown to be more likely to be true than the emission theory, as the light did not accelerate and the angle did not get smaller. Now, this is extremely important because this is in 1862. And remember, going back to Airy, I'm not going to go all the way back, but if we go back to Airy and Arago, actually, Airy hasn't happened yet. If we go back to Arago, remember their interpretation was that there should be no change, that a moving refractive medium is the same as a stationary refractive medium. But Fresnel just measured a change. And then also we know that there's transverse motion that's translated 1-to-1. So, and this gets translated 1-to-1. So there should absolutely be an angle change when you introduce a medium to starlight. They've experimentally substantiated what would happen in the lab. And then Michelson also ended up doing variations of this experiment for a number of years, about 10 years, I think it was. We're just repeatedly finding the same thing and with more precision. So, and that's what he used those principles to help him make the Michelson interferometer. Yes, Stone.
Speaking of going back to Fresnel, I just DM'd you on Discord an updated image.
Oh, no way, dude. You knew I wasn't going to do it. And you made.
That's how easy it is. I'm kind of
My-
shaming you,
My
but I'm also
freaking-
helping the crowd.
My freaking gag.
Because I really don't like that image there. That one we were just looking at right there. It should look like this. And here's why. Is because outside of the blue medium in the pipe, light should always be moving at C at the yellow velocity. So when we look at when it's passing through the pipe, you got to keep in mind that both the blue and the red here are both going to be slower than the yellow, but it's a degree of how much slower. And because above, the medium is moving against, as well as being denser, it is also moving against the direction of light path travel. Propagation. It is going to be seen as the relative redshift between the two, where you're actually perceiving these both at the eye finally. And down below, where your light propagation direction is in the direction of the blue medium, that will be perceived as the quote blue shift of the two slower speeds when you finally recombine them and produce this fringe shift. I hope that makes more intuitive sense than the crappy illustration that I've just replaced. If you know what I mean. This is a little more how it should have been drawn in the first place.
Thank you, sir. Much appreciated. And yeah, so like you were saying, that represents the longitudinal drag when you're going, when you're parallel to the direction of motion. And then the transverse, which is when you're 90 degrees to the direction of motion, was fully substantiated there. And then, like I said, Michelson continued on a number of variations of this experiment with more precision and kept finding the same result with more accuracy. So fully substantiating the undulatory theory superseding the emission theory there. And then, of course, we have Maxwell, who comes along in, I think it was 1865, I want to say. Let's see. Yeah, 1864. He comes around and using the electric and magnetic permeability constants. So here we have the vacuum constants, which they measured in a vacuum, and then he does the inverse square of that, and that comes out to give the numeric value for the speed of light. So that number we looked at earlier, that 299,000 kilometers a second, that comes out to be derivable from the inverse of these two properties in the same way that the speed of a medium is dependent on the density of the elastic medium. So same kind of ratio that we're looking at here is dictating the calculated value for the speed of light and the vacuum speed. All right. So let's see here. So, what principles did Doth one derive the speed of light under? Do you ask, my good sir? Well, in his paper, A Dynamic Theory of the Electromagnetic Field, he describes a sea of rotating vortices that translate their centrifugal force to the wave mechanics that are going on in the medium, and that provides the speed for the speed of light. So essentially, a bunch of little vortices that are made up of material particles that that have the values of the permeability and permittivity values of whatever material values that would be, that they're swirling around at the speed of light, and that is translating waves that propagate through that at the speed of light, is what he's putting forward in terms of a mechanism. And that's how he describes how lines of force work and all that. They're shears and twists within that medium. And then that's how he describes vacuum polarization and all of that as well. So like the ability to polarize a vacuum, like how crazy is that? You can just you can polarize a vacuum, but there's nothing in it, guys. But
You
anyway,
polarize that section of nothing. But
just
that's cool.
just a localized polarization of nothing. Nothing relative
Nothing,
to it.
nothing to see here, buddy. Move along.
That's so funny, dude. But yeah, these are the principles in which they were derived. So keep in mind that if you're going to propose a new theory but using the same mathematics, you're going to have to show like how you're going to physically derive everything differently. So we're going to definitely take note of that when we audit the relativistic paradigm here as we're coming up on it as we reach the early 1900s. But again, just showing that ratio there of the speed of a wave in an elastic medium, which is given by the density of the medium and the resistance compression. So by using the square of that, you can derive what the speed of sound is in any medium. And same form is all I'm pointing out here. And then in 1868, there was a man named Hoke who, applying the Fresnel drag formula to an early rendition of a Michelson-Morley interferometer, or rather, actually, he just kind of redid the Fresnel interferometer, or I'm sorry, Fizeau interferometer, where he used half-covered shielding, where only half of the path of light was traversing through water. It's like, and let's see. Sorry, I had to read a text message real quick. Okay, so anyway, he determined that if there was no change, then that meant that the Earth was in motion, because that would substantiate the hypothesis that there was a stationary medium that's dragging the light in the opposite direction of motion for some reason. And so when they did their measurement and they didn't get any shift in the interferometer, despite rotating it, taking measurements throughout the day, etc., he didn't get any change. And so he was like, oh, you know what? That means the Earth's in motion. And they determined that you couldn't make a measurement of a first order relationship of the velocity of Earth to the velocity of light, which means, in other words, with respect to this medium that they were conceptualizing and basing all their math on and deriving everything off of. And that's extremely important, because once they give up the first order interpretation, and the first order being like the original V over C that we looked at, so the only ratio they ever got was for aberration, and then they're going to turn around and say that that the fact that there's no change when they add a refractive medium means that they're um, means that's exactly what they predict, because there's some mechanism carrying it in the opposite direction, and it's basically creating the illusion that's hiding the first order effect of the velocity change. And so we're going to look at Michelson's apparatus and how he tried to come up with a second order detection, and then used a second order uh, derivation of the Sagnac effect to derive the frequency change. And but it's important to note here that giving up the first order relationship of the velocity of Earth to the velocity of the ether is insane. And then because they could measure it for literally everything else, except when they tried to do the Earth through space, they could never get the measurement. So now they're going to invent a literal special theory, to take over here. So we're looking at a transitional period here, because this is going to be this was the last first order attempt here to get a V over C relationship, and then they move on to second order only. So Klinker-Fuse came up with a zenith mount, and you put turpentine in a telescope, and looking at a star as it moved across the zenith, he determined that there was a change, an aberration, in the way that we looked at earlier, where they were measuring a change in the angle when they added a medium, and then how much velocity would translate to the angle change. Well, a guy named Klinker-Fuse, prior to Aries, a couple years prior to him, said, "Hey, when I put turpentine in my telescope and look up at the sky, I get the angle change that is proportional to the velocity of Earth, causing it." So he's like, Aries, like, "No way. Let me double check you. Let me fact check you, bro." Back in the day, when you fact check somebody, you didn't outsource it to a company that had an ambiguous CEO or morally ambiguous CEO. You actually had the lads build you an apparatus that was equivalent and or better than the experimental apparatus that said that they did the original thing, and then you confirmed it yourself. So what we're looking at here is Aries Zenith mount, which was a huge technological feat at the time. There's an awesome video on the ManofStone Rumble channel. If you go to rumble.com/ManofStone and check out his couple of thoughts about Aries, I think that video.
Just to be clear, that's /FE ManofStone, no spaces. And yeah, it's a couple thoughts about Airy. Yes, indeed.
Yes, couple thoughts about Airy. Check that video out. My boy goes in deep on the technical specs of this thing. But to be short, they were using micrometer wire, which is 1/millionth of a meter in thickness, and then making a little grid out of that. They were able to relate the change in arc seconds to a terrestrial meridian. So they were able to come up with a really precise way to measure the change in the position of the stars. So when Airy looked through his zenith mount here with water filled through it through his eyepiece, using a grid of crisscross 75 micrometer wire, and he didn't measure any change, he concluded that he thinks it's not justified in concluding that, or he thinks it's justified in concluding that that Professor Klinker-Fuse's hypothesis is untenable. And real quick recap on Professor Klinker-Fuse's hypothesis. His hypothesis was that if the motion of Earth were real and not apparent, then when you add water, when you add a medium in between you and the starlight, that Earth's real motion will it'll be physically in a different space, in three-dimensional space, because it had more time to move as the light comes through the telescope at a slower speed. So there has to be a real angle change. And he said that this is independent of any effects of an ether. And he goes on to derive his equation just using Snell's law and the classic V over C relationship, which implies an ether with respect to a medium mechanistically. But he was with respect to the lab experiments from Foucault and Michelson that were going on at the time, he was like, look, independent of how we think about it, like, real motion creates a real change. They're measuring it in the lab, boys. So I don't know why he lied about his turpentine measurement. But anyway, Airy went on to measure that and didn't measure a change. So he says it had it been retained, the aberration implied in the corrections would have increased by 15 and had been minus by 15 throughout the year. In other words, there should have been a change in 30 arc seconds over the course of a year, but that wasn't what was measured, because that would have corresponded to the to that full velocity ratio of aberration for the V over C. And that's not what was measured. It was actually a really, really small amount, much smaller than what was considered for, to be substantial for the heliocentric model. So they basically write this off as being, no change present. And from that, a lot of the modern interpretation is that this implies that that the change in aberration is that this is okay, but this is not okay. And Aries isn't like this. His paper isn't going to tell you, "Hey, we falsified our belief system," right? He's commenting on the facts of the results. He just says that it was unchanged, which is experimentally true. But the implication here now, by adding the medium and doing this even more precise measurement than what Arago did, is that the starlight already comes in at that angle, and they go
Yeah,
on to
sorry, Alan, using the quantified expression, what Airy got in his results, numerically speaking, was 2.6% of the expected amount.
yeah, so straight up nothing in terms of substantiating heliocentrism, at least, which is really bad for them. And so from this, so you would think, okay, they must have a straightforward, cohesive explanation for this, because they somehow still all believe that the Earth's in motion. Well, several mechanisms.
Undeterred.
Yeah, undeterred. Several mechanisms were proposed to explain this, and one was kind of building off of the backbone of earlier, where they were just saying that the ether is being dragged in the opposite direction due to some unknown mechanism. It's just bouncing around in there, because their conceptualization of ether was that it was stationary and it wouldn't have any motion to impart on the telescope. So invoking this as very ad hoc for them to say that it's carrying it in the opposite direction of the motion to create the illusion. And then another explanation would, of course, be you could do a Lorentz transformation between the observer and an observer on the sun, and you could say that the wavefront already comes in at that angle because of the relative motion between you two. And when you look at that through the lens of the transformation, you're not going to see any, relative motion change in your reference frame because of the constancy of the speed of light and the way that they interpret that through the relativistic paradigm. Even though it's literally going through a medium and it's going to be slower, they still come up with a convoluted way to interpret it as being a constant. So anyway, they impose an already moving wavefront on you, which is our position anyway, that the Earth is stationary and the wavefront already comes in at an angle. But then they take that and they say, well, if you transform to the sun, you would see the angle change for the observer on Earth. And for us on Earth, if we were looking at an observer on the sun, we would see their angle change, but never ours, because we're in the frame that's in the that's in the relative motion. So it's always, when you were a kid and you were playing Mario and you got to the end of the castle and it was like, sorry, dude, your princess is in another castle. This is this is an early version of, sorry, dude, your velocity is in another experiment. All right, so continuing on, we have Mickelson Morley now. Now, this is a really important one because this is the last ditch effort here to get a second order ratio of the velocity of Earth moving through space at the proportional speed that is required by Kepler's laws, and at this point Newtonian dynamics, because at this point they had merged Newtonian dynamics with Kepler's laws, and so because you could derive one from the other and the way that they frame it now, you could derive Newton from Kepler, but they derive, it's backwards. Kepler was first. You could derive Kepler from Newton, and Newton's equations default back to Kepler's, meaning Kepler's are more fundamental than Newton's, because of that relationship, it's like a lesser known talked about thing, but if you confront an astronomer on it, like they know the significance of that relationship and it falling back to just kinematics. So they really need a substantial measurement of the frequency change in light to substantiate their belief system. That would be huge for them. So Michelson comes up with a way to he's like, okay, look, we got this crazy ether mechanism that's somehow canceling out the first order effects. If I come up with a way that light will traverse this apparatus in such a way that the first order effect will be canceled out, but there'll be a little bit left over for, as it comes back on its path, and we'll capture the difference in that path link change. So that was the idea here. So before we get to the construction of the apparatus, we're just going to quickly go over the math and the state of things in 1887. So there's a comment here at the intro to the Michelson paper on Airy's experiment here, and it says it's talking about the undulatory theory versus the emission theory, and how the emission theory got falsified because it failed to account by the fact that there's an angle change when you impose a medium in velocity, which was found by Foucault and Michelson, years prior. So this new explanation was more simple than the former, but it failed to account for the fact proved by experiment that aberration was unchanged when water was added to the telescope. So it became a real conflict to try and explain how you could have motion of an Earth at 30 kilometers a second with respect to a medium, this wave mechanic, undulatory theory, wave mechanic, and then not have a change in the refractive index for Earth traversing through space, because they're measuring in the lab, but not through absolute space, which is detrimental for them. So for if the tangent of the angle of the aberration is the ratio of the velocity of light, so if it's just that simple V over C relationship, then since the latter velocity is in water is 3/4 the velocity in a vacuum, the aberration observed in a water telescope would be 4/3 its true value. So in other words, he's saying, basically based off of experimental measurement and the ratios involved here, we can calculate exactly how much the angle should increase based off of the slowing of the speed of light as a ratio to the velocity of Earth to that change in the speed of light. And he says here, it should be noted that most writers admit the sufficiency of explanation according to the emission theory of light, while the fact of the difficulty is even greater according to the undulatory theory. For the emission theory, the velocity of light must be greater in the telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the motion of the water in the telescope carries the ray of light in the opposite direction of motion. So keep in mind that's Michelson commenting on how absurd they have to, ad hoc make their position to keep their philosophical position and mathematics in line with Kepler's laws and, this framework that they're putting forward to describe the cosmos as physical. So as we get into the math a little bit here, all we're looking at here is a timing difference change based off of the light traversing the apparatus longitudinal and perpendicular to that. So basically he's what he ends up doing is he ends up doing a Taylor series expansion to look at the magnitude of the order of timing difference that would occur based off of, let's say we have, a starting point here. This light is going to be reflected X amount of times traversing this interferometer. It's going to create a path length that's 72 meters. So over the course of, the time it takes for light to traverse this 72 meters here, how much is the Earth going to travel out from underneath it, so to speak? Well, actually, not so to speak, exactly, pretty much. And how much is that going to affect the wavelength here? So on the second order here, he gets ratioed against the velocity of Earth to the starting wavelength of the velocity of light that they're using. He comes out with the amount of fringe shift pattern that's going to be created by the interference, due to that frequency change as a ratio of the velocity. And what he comes up with for that is that there should be a just over 0.5 fringes, and what they ended up measuring was just over one fringe, which when you ratio that in terms of the measuring the distance of this fringe and then squaring that distance with respect to the measuring the distance as a function of the wavelength that you started with, and then squaring that distance, you get 6 to 7 kilometers a second, which is much slower than 30 kilometers than the 30 kilometers a second that they needed. And we can see the theoretical curve here for what they expected to measure. This is going in the east and west directions as they rotate it, and then what they actually measured was this black line here, so just over one fringe, and it changed a little bit throughout the day, but never to the magnitude in which they would need to substantiate their velocity on the second order.
Exactly. So here we were looking at an experiment where they're getting 20% of the expected value. And again, mainstream calls it null. That value is a null value, that it represents essentially zero, that you should toss it out as a defective reading, so to speak, that the whole device must not be correct, that there's got to be some other reason why we're only getting 20% of what we expect to be getting. And even Airy, he got 2.6%. They called him a failure. So we've gone from failure, now we're up to null. That's kind of where we're at in the paradigm on the timeline.
Yeah, no, great recap, man. And with the precision of this and their understanding of the relationship of frequency change and velocity at this point, and through measuring Fresnel drag and the rotating mirror stuff, they knew to a high degree of accuracy, what the implications would be if this measured, a null. This would mean that there's no relative motion between the Earth and the ether, which would mean that the Earth is stationary, and they can't. That would give credence to that position. You would be able to argue it real easily, a direct equivalence, because that would be the only interpretation that you could make out of that if your velocity isn't corresponding to the mandatory velocity that's needed for your ratios to work to explain the heavens. So this was a really perplexing situation for them, and the only way that they could explain it was through relativity theory, which we will get to very shortly. But before we get to the relativistic paradigm, to explain this, we're going to make a quick note of the math here that's used. So this is 2 times the distance over velocity squared over v squared, or times 2. This is 2 times the distance times velocity squared over the velocity of light squared. And the 2 times the distance is just for the geometry of the apparatus. So it's creating a reflective beam. So it's going there and back. So it's doubling the path length essentially. And then the velocity squared and the velocity of light squared is just a higher order degree in the change based on the ratio of the velocity. So it's just looking for a much smaller fringe. So when we were looking at some of the fringe patterns earlier from the Jones rotating plastic stuff, those fringe patterns would be, much bigger than what was measured here. But in any case, like Stone was saying, they wrap this up as a null and say that this measured isotropy in the speed of light, meaning when they rotated this, there was no fluctuation. But here we're looking at a positive and a negative on the east and west directions there as it was rotated. So there was a change there. That's not isotropic. That's called anisotropic. But anyway, they go on to say that this proves isotropy. So if someone says that this proves the speed of light is isotropic, just be like, hey, did you know that there's a change here in the east-west directions? It doesn't. Why does it do that?
You're arguing with the people who use terms like curvilinear in their heliosexual model.
Dude.
You know what I mean? There's no winning. There's no winning there. Keep that in mind.
That's so crazy, bro. Literally rotated the device and it flipped the reading stone. Dude, they're like,
that's null.
They're like,
that's null. That doesn't count.
But it's isotropic, dude.
But it's not close enough to the dotted line, so it's null. Nuh-uh.
Oh man, they pranked us so good. All right, that is profound. But yeah, anyway, so later they're going to use some very familiar equations to describe this quote unquote anisotropic measurement here. And keep in mind, this isn't an apparent frequency shift due to observer's relative motion or instrumental error or something. This is a actual physical displacement that's measured in the timing difference in which in which light traverses this apparatus. Because what happens here is this creates a cross where there's a north-south beam and there's an east-west beam. And so when the device is orientated north-south, there's a perpendicular east-west beam. And as they rotate it, they're looking for fluctuations in the speed of light when it's perpendicular to the north-south directions. So when it's orientated east-west, they're looking for an east-west difference. And what we're looking at here, as they're rotating this device on this graph, we're seeing positive, negative. This is the like so in other words, going with the medium, going against it. Velocity boost, velocity reduction. Now, this is exactly the thing that they were looking for, but to a higher magnitude. And Stone, as Stone just said, they were just like, you know what, we just got to throw it out, dude. That's that's hilarious. Shout out to
that
the
measurement
labs.
that one right there is defective. That's a defective measurement. That's what they call it.
When I say null, I just mean not what I wanted. That's not what I wanted, so therefore it doesn't count.
Yeah, and keep in mind, it's you'll never get any sort of pattern out of the Michelson-Morley data or anything other than what we have here, like in terms of periodicity or anything, because they actually gave us fragmented data sets from like a random interval from the larger set that they took. So all we have on record is just this set to show that even within this, it shows anisotropy in the speed of light, meaning a change in its direction dependent, and they claim that it's isotropic, meaning in any direction it should be the same. So this bar or this graph here should just read a straight line. It should just be positive or slightly under it at all times. It shouldn't be positive in one direction and negative in the other one. That's absurd. Okay, so we'll move on now. I think we covered that pretty good. All right, so now we're going to look at a man named Voldemort Voigt. I think I nailed that, Stone. What do you think?
Oh, that was perfect.
Thank you, sir. So this young lad here came up with he had some thoughts on Doppler's principles and how to do transformations to describe wave mechanics for what an observer in relative motion to a stationary observer would see, or an observer in relative motion to him, etc. So anyway, what he goes on to start his paper with is he starts with saying that it's well known that you can derive the velocity of light through with respect to an elastic medium, and he goes on to show how that works out with some differential equations. And so he starts that off as the baseline for what he's going to do with a transformation using xy coordinates from said differential equations being derived from an elastic medium. So basically taking a slice of the conceptual medium and then like how that's going to represent mathematically what's going to happen in reality to waves with respect to that medium in reality is what's being translated here mathematically is what this is supposed to represent. And he's going to define coordinates in three-dimensional space as x, y, and z as derivatives of the as derivatives of the coordinates or field equations themselves. So as he continues on here, he derives his transformation. So I talked about how he's going to describe how a wavefront is going to change for an observer in motion and what effects the motion is going to have with respect to that wavefront with respect to an elastic medium. So to make the to describe this, he comes up with this equation here, and he ends up with this transformation. And this is the first known iteration of time dilation. So what we're going to realize here as we continue through history, now keep in mind this was in 1887, same time as Michelson-Morley. He dropped this derivation here. But what we're going to see is that in 1905, this exact same transformation is going to be reused under the premise of relativity theory, which describes this transformation, which describes this transformation with respect to no medium. But we're going to see how we got there. So we see this time component here is being translated through. Actually, where's the sorry, right here. So in equation 10 here, we see the transformation for the time component. We have tau equals t minus distance times velocity over the speed of light squared. And what this implies here is that because it puts time in here minus the change in position over the speed of light squared, this implies that time is now dependent on position, which is dependent on velocity over the speed of light squared. So this gives the implication that time is like, if you were to remove the physical medium from this and interpret this in terms of the coordinate system representing three-dimensional reality, you could misinterpret this as non-localized, or as like time not being absolute and just being a function of velocity. And that's exactly how the relativistic paradigm portrays this coordinate system without the medium. But what he's actually describing here is the change of the oscillation rate of waves with respect to a medium as a function of velocity to facilitate that change. And that's all this describes. He never makes any claims about the speed of light being an actual constant or anything, but it is an outcome of the transformation. It does preserve the original wavefront under transformation, which was the purpose of this. And it wasn't to establish the speed of light as a physical constant and say that reality changes. It was to compare what a moving observer would see with respect to a stationary one and preserving that original wavefront under transformation. So these effects that are described here are, again, oscillation changes to the frequency of electromagnetic radiation, not changes in dimensions in three-dimensional space. So extremely important distinctions, but mathematically, this is correct to do, t minus the distance times the velocity over the square of the speed of light. That would be, correct mathematically, but physically this leads to implying that the, time is local and not absolute, and it's a function of velocity, but that's not what it represents. It's just a quick way to do the transformation, and we'll see the equivalent here. So let's say that he never did that transformation that way. He didn't include time as a component that way. He did the transformation this way, where it's t prime or tau is equal to position over the speed of light times 1 minus velocity over the speed of light. So that's going to be, your positive, or, traveling with or against the observer, like, coming, receding or approaching. But anyway, that's exactly equal to the same transformation there, because if you expand this out, the change in position over time, leads to this. So it's these are the exact same, but this one leads it less physically confused, leads less ambiguity for the physical confusion, but there's no difference in these. It's just that this one gives the appearance that time and space become mixed. But again, it's just describing the change of waves with respect to the transformation. And then there we have the Q term from the Voigt paper, which actually goes on to become the gamma factor, which is the inverse of 1 over the velocity squared over the speed of light squared. So this ends up coming out to be link contraction and time dilation. And another awesome video that can be watched about link contraction and time dilation is on rumble.com/FE ManofStone. Couple of thoughts about Einstein. You'll see what we like to call around here the hockey puck effect. And that's if you scale this out on a graph.
Hockey stick.
Oh, sorry, I don't know my sports nomenclature. So we're going to be passing the pigskin around here. And what we found is that when you graph this out in terms of change over time and position, it makes a hyperbolic curve as you increase velocity. So as your velocity gets closer to C, instead of having a sharp linear straight line, it ends up curving like a hockey stick, and it never approaches, or it never exceeds the speed of light. It just curves to a hockey stick and just goes right along with it. But this is what creates that hyperbolic curvature. It's the mixture of these terms here, the squaring of the squared terms there. So that's how we get into when they talk about space-time is a manifold, and space-time and special relativity is flat, and space-time and general relativity is curved. All that is talking about is the like how it plays out on a graph. Like a manifold for them is just taking, like, imagine you have an infinite graph, but it's so big you're never going to use all of it. You just need a small section. So you just take a little section out of it, and these little sections of flat space-time and curved space-time, these are all functions of how things change on a graph. This has nothing to do with reality. And again, they directly describe the same changes of wavelengths and frequency versus changes in physical distance and local time for an observer. We have Lorentz Fitzgerald in 1889 using the same equations to derive his theory. He was doing some experiments with an electron and measuring the frequency change of an electron. And he found, if you go back and look through the history, you'll kind of see that Lorentz was the first to discover time dilation with the electron or something like that. It's some kind of story like that where he wasn't quite sure what was going on, but it ended up being time dilation. Well, he's using the same equations there, and his interpretation of it was that it was a frequency change, not a change in physical reality. Although he did say that perhaps that the molecular structure of material objects could change due to the compression of the wavelength change of the electric and magnetic fields, which are binding everything together. So he was kind of proposing link contraction as a physical mechanism, but it had like the component of basically objects moving through the ether will be compressed by a proportion of their velocity, but the physical mechanism itself is that the electrons that hold the material matter together, the frequency of the electric and magnetic fields that are created by that are compressed. So that was an actual physical mechanism that was proposed to explain something like Michelson-Morley, and that was kind of what they put forward there for a little bit. They ended up going with that by saying that this amount of compression happened with respect to the apparatus when they had it in the east and west directions. And keep in mind the amount of wavelength change that comes out of these equations to describe how much physical reality changed is much smaller than what was measured. That little tiny amount that they measured that was just over one fringe is way, way bigger than what they predict for link contraction and time dilation. So they actually, like Stone was saying, they have to just throw this whole thing out and call it a null and act like it proved the isotropic speed of light, meaning that it's the same in all directions. And that's not what happened at all. And these equations describe a much smaller effect, so they don't even have any ability to govern this experiment. Because what we're going to find out through Sagnac is that these equations that describe this, it doesn't matter what configuration you make this, if it's a cross, if it's a parallelogram, if it's a circle, it doesn't matter. It all measures the exact same thing. So this ends up being a first order interpretation rather than a second order. So none of this, so relativity doesn't even have any experimental or any dominion to even try and explain the fringe shift change, because they predict no fringe shift change. They predict that the path lengths are the same in all directions and that there's no change in the speed of light, which results in no physical fringe displacement. Okay, so again, here we have Lorentz just kind of talking about that, which is what I went over already. And he's just talking about that second order v squared over c squared relationship. So again, just kind of reiterating, these equations have always been used throughout history to describe changes of wavelength with respect to an elastic medium. Never changes in time and space in the way that they've redefined it so that they could make a quote unquote null reading a prediction of a cosmology that's in motion, described by coherent physics. But here we have the most interesting term of all, because here we have Lamar's theory where he puts in 1897 he has a dynamic theory of an electric and luminiferous ether, and he gets into how the wave mechanics would work in this elastic medium. He describes the dynamic effects, and the dynamic effects, of course, being the frequency changes that occur with respect to the wave that is going through the medium, and the changes in velocity that occur, as a result of velocity. So as he goes through the math here, he ends up with this half order term, this 1/2 times v squared over c squared. And this is extremely important because earlier when we were talking about the transverse and longitudinal Fresnel drag, well, there's also transverse and longitudinal Doppler effects. And Doppler was saying that he disagreed with what they were putting forward to explain vacuum polarization and transverse motion, and he doesn't predict any change because there's no distance change at that perfect 90-degree angle. So therefore, there should be no Doppler frequency shift. Now, in relativity theory, they end up using this half-order gamma here to claim a mutual exclusive time dilation shift in the frequency of light, independent of the motion of the receiver, and also independent of like transverse or longitudinal. So it's gonna appear no matter what, because it's a function of time dilation, and time is physically disconnected from absolute time. So when you're moving at this really fast speed, you're gonna have this half order effect come out of the Doppler frequency if you were able to measure it when we get into really fast speeds. So we'll see how that was experimentally accomplished here, but just kind of giving some background on what this is supposed to represent for the relativistic paradigm versus the ether paradigm. So for the ether paradigm, this just represents retardation or velocity addition of a wave with respect to no, I'm sorry, this isn't plus and minus, this is just retardation. So this describes retardation of a wave with respect to velocity, and this is going to be applied to the emitter here. And then, so that's what he's putting forward in terms of how things are going to change. Now, a really important ratio here, because again, if you were to look at this through if you were to go on Google and go through the Wikipedia mainstream paradigm narrative, you would be led to believe that the ether theories don't predict this, and that this half order gamma term is this miracle of relativity theory. And when it ends up getting measured, to this ratio, they're going to take that as like, oh, this is the ultimate, how could the theory not be true? The math predicted it. No other theory predicted it. Well, here we're looking at a theory in 1897 that predicted the exact same effect and gave their full derivation of deriving everything under the principles of an elastic medium, solving, pulling out the coordinates from the differential equations. Same principles that we that Voigt derived his stuff under. They were all doing the same thing. So here comes Einstein in 1905 to re-represent the ether equations as distortions in physical reality by mechanism of dilating time and physical length contraction. So he proposes in his 1905 theory that all inertial frames are equally valid, meaning if you're moving in uniform rectilinear motion, you're not able to detect a change in motion because you're going to be experiencing length contraction and time dilation in the direction of motion. So you'll never be able to measure it. You would have to do a transformation and see what the difference would look like from the stationary reference point. Now, and then in addition to that, he makes a second postulate that the speed of light in a vacuum is constant and independent of the motion of the emitter and the receiver. So this is the second fundamental background of how he's going to explain the Michelson-Morley experiment. Now, keep in mind, he asserts these postulates at the beginning of his paper. He doesn't give any mathematical derivation. All of the ether lads start with "it is known," blah blah blah, and then show the mathematical derivation for it. Einstein says, "This experiment happened this way, therefore this is what it is now." That's not the way to do it, and we're going to look at how he tries to derive the speed of light independent of velocity, as he asserted in his postulate at the beginning of his paper, as we continue. But we're just going to look at the effects here real quick. So the familiar time dilation now, instead of being a change in the frequency and wavelength, it's going to be a change in your local coordinate time. And for length, that's going to change as a function of velocity. So instead of the wavelength of a wave changing, or the magnetic field length of lines of force changing, or anything like that, like they were describing, instead of that changing, it's going to be the actual length of the apparatus. The physical bodies are going to change as they move through nothing, but just velocity is just going to change it. And then so that's what we're looking here for. And then we got the gamma factor, of course, which is the 1 over the square of the squares of the velocity. And then he goes on to introduce the half order gamma term there as well. But before we get to that, that's just noting the effects of the transformation, the reinterpretation of what we looked at earlier from Voigt. But in addition to that, he asserts correctness through saying that he satisfies the laws of kinematics and parallelogram velocity addition, which I'll get to what that means here in a second. But what he goes on to show is that by introducing a term that normalizes the speed of light under velocity addition, which just is a fancy way of saying that if you add a velocity to the speed of light, when you do it through the way that relativity describes it, it's going to come out such that you're never exceeding the speed of light. You're always going to be under the speed of light. And that can be represented by that what's it called? What's the word I'm looking for, Shane? Logarithmic, not
You approaching zero but never reaching it, or some sort of other hockey stick graph?
There's a word. It's not.
You talking about normalizing?
Yeah, but there's a word for describing that anisotropic curve where, or like that curve. There's a specific term, but I can't remember off the top of my head now. But anyway, when you hit that curve point, you can never hit zero. You can never hit the speed of light. It's always going to be reduced by a factor of the speed of light such that it never exceeds it. So through that normalization technique here that we're looking at under transformation, the speed of light is never exceeded. So at the end of his velocity addition terms, by assuming that the speed of light is constant between observers, irrespective of their motion, he comes up with this equation here, where the velocities plus the velocity of the speed of light over 1 plus the velocities times the velocity of the speed of light over the speed of light squared is just is how he normalizes that and makes sure that it never exceeds the speed of light. So we're going to look at a really cool thing. Earlier I mentioned the parallelogram velocity addition thing. So that is a kinematic thing, which is a really cool concept. We'll take a look here on this awesome graph. Shout out to our librarian Eric who found this. So in kinematics, let's say you describe your coordinate system here, starting with your XY point, and you draw out vectors to describe the magnitude and direction of the motion. So what that's going to make is a parallelogram. And then if you do the opposite, so if because in kinematics, relative motion is always true. So if you reverse the magnitude of it, it will create a parallelogram. So in classic physics here, we're looking at a velocity of 0. So both relativity and classic physics here have no deviation here. But then as you start to add velocity to it, you get the changes in time and space there, and that gives this parallelogram that gets created here. And when the law of parallelograms is that when you add up the angles, you get 360. So by doing that, you show good completeness of your math, and that the kinematics and that the laws of kinematics are satisfied, because you can complete this geometrically based on the velocity composition that you're putting forward. So as you can see here, though, we have a hyperbolic deviation in the parallelogram created for relativity. So the black line represents classic velocity addition. So this is always going to equal 360 when this parallelogram's angles get added up. But we have this red one and dotted line here. This is the relativistic one. And as the speed increases here, you see that this never equals these angles when you add them up are never going to equal 360. It's always going to be less. So this is the hyperbolic nature of the equation that we just looked at. This is what this is part of what this describes. So when we get into, or when they get into describing relativity as hyperbolic geometry and curvature of space-time and curvature of a manifold and all that stuff, that's all just represented through plotting out the geometry of the math, based on the functions that he imposed to make the speed of light the same. It doesn't necessarily have to have anything to do with physical reality, but it does graph out really nice. And this is what this looks like. So as you if you were to get to the speed of light, you would see here that it goes to 0. So there's just there's no parallelogram now. Everything gets obliterated. Nothing works. But
It's nonsensical, but it's
yeah,
pretty.
but it is pretty. It is very cool. So that's what that represents there. Very awesome stuff. So we'll get back to the Prezi here. Present. All right. So with the laws of kinematics satisfied, he's like, that's so awesome. And then to further reassure himself that he's extra correct, if you do a velocity that's slow, right? When we look back at that graph, well, when the velocities are 0.1. This is so perfect. Okay. So if the Earth is moving at 30 kilometers a second, that ratio to the speed of light is 0.01. So we're looking at the deviation here in the parallelogram that's created from classical Newtonian velocity addition versus relativistic velocity addition. And in case you can't see it, it's because it's not really there. We got to zoom in. We got to hella zoom in there. So if we're moving at the speed of light, that's the deviation there. Almost not noticeable. But anything, sub that, it's kind of hard to move the scale there. But basically, he's saying that if you're not moving this fast, there's basically no deviation, and you could just approximate this as the Newtonian approximations. So if you're moving at anything lower than 1% of the speed of light, which would be 30,000 kilometers a second, this is the kind of deviation that you would be looking at. But we're moving at 30 kilometers a second, they say. So this is what we're looking at. And in this range, we're in the range that just falls back to Newtonian approximations. Extremely important concept. Were you about to say?
Are you able to enter your own value to the right of the V on the slider you were just manipulating? Yeah, can you click and just enter the number, and then it'll just show you that?
Oh yeah, I can. So I can
there you go.
You can just make it smaller.
Punch enter, and there you are. Perfect.
There we go. So yeah, as you get slower speeds, like what we're dealing with, terrestrially on the ground, we can see that the deviation from relativistic and classic physics is nothing. We have to zoom in on this insane scale to look at any differences there. Okay. All right. But yeah, falling back to the classic then. So he turns to the Fresnel drag experiment where the speed of light in a moving medium was measured. And if you drop his terms, then it falls back to, that. And so he was like, look, this is proof that the speed of light is the same and it's being dragged, by the velocity of the refractive medium, and not with respect to any sort of ether mechanisms. It's just a function of the reduction of my velocity addition equation. So he completely co-opted. This is how they co-opted all the previous experiments that started that gave null results for the motion of Earth, but gave measurements in the lab that were c plus or minus v. So they were just like, look, if we just drop the cosmological velocities, we could just use classic stuff in the lab and we're good to go. But when we use our cosmological velocities, we use this component here, and we can determine that we could never measure our velocity through space because there's nothing. And that was in 1905. And so Sagnac came along in 1913 and was like, there were specific claims that were made throughout the paper regarding ether mechanisms and where Einstein's equations apply, in particular any closed polygonal circuit in uniform rotation or motion. His equations should apply, so those transformations and all that should be valid. So Sagnac goes, okay, cool. Let me introduce you to my rotating turntable here. So what he has is a light source and a photographic plate. and he has a path of light that's going to be traversed on this rotating turntable. That's going to where the light path is going to be. It's going to be split, so it's going to go clockwise and counterclockwise relative to the rotation of the turntable itself. And so that's going to create a change in the frequency and wavelength of light emitted, which when it recombines, should create a destructive interference pattern proportional to the rotation rate of the device. And Sagnek measured exactly that. We pulled here the equation from his paper. This looks very intimidating and long, but when we break it down, all he's saying here is that we already talked about how they didn't have the ability to measure the actual wavelength on these apparatuses. They were just using photographic plates to measure the fringe pattern created by them, but you could infer the wavelength change by multiplying it by the fringe pattern there. So because he's got clockwise and counterclockwise, and he's rotating it, he 4x's it there. So what the fringe, so basically it's just the wavelength change is going to be proportional to the fringe. That's how he takes care of that ratio on this side, which comes out to be just the total distance of that light had to travel along the apparatus times the angular rotation rate of the apparatus, and that's going to over the starting wavelength of light, and that's going to give you the change in the the changed wavelength based on the frequency there. And when we write this in modern formalization here, we have the modern Sagnek equation, which is just the classic Sagnek effect, which is just 4 times pi times the distance that light had to travel times the angular rotation rate over the starting frequency of light, and the delta phi there is going to be the change in the frequency that's produced by that rotation rate. And that's exactly what he measured. So he was like, yo, Einstein, your theory is completely wrong. Einstein never commented on this, never replied at all. It actually got passed off to a number of mathematicians to try and explain this, primarily one being Paul Langevin, who we talk about a lot here, who I primarily mispronounce. So that guy was put forward to explain mathematically the how relativity actually predicts a first order timing difference in the speed of light with respect to an inertial observer as defined by the postulates and holy scriptures of relativity theory. When you read through it, you can see where Einstein defined explicitly where his equations should apply in the scenario where Sagnek applied his equations. But you'll notice here he's using first order ratios and not second order squared functions, which would be much smaller effects. Now, in the modern interpretation for these apparatuses, they do over c squared, which gives a much smaller effect to look for, which means you have to have a greater angular turn. Yeah, it has to be, fat. You have to be moving faster, and the turn has to be greater for the effect to be registered in the device there. So the way that they dress it up now is they've got inertial navigation systems that are overtuned and looking at doing the analysis at a higher resolution than what's needed. So it's hard to determine the noise from the velocity, and it adds ambiguity to the functionality of the apparatus. And when you look at an INS manual, you'll see that the way that they have it calibrated, if you were to just operate by itself and it was trying to determine your position and location, it would be way off, and it requires constant GPS corrections. And I think it's made that way on purpose, because they don't want it to be known like how accurately a gyro can measure linear velocity. And that's exactly what happened in 2004 when a guy and his team measured the Sagnek effect in a linear configuration gyro. So they took a gyro here and then unspooled it, came up with some configurations that gave linear segments, and measured motion in such a way that defies relativity theory, where the motion of the detector and the relative motion of this portion of the fiber shouldn't produce any motion because they're moving at a constant velocity. And as defined by relativity theory, That's inertial motion, so there should be no fringe shift pattern produced. Yet they measure it. They measure it when the detector is stationary. They measure it only as a function of the segment of the link that they are moving. And in a parallelogram configuration, they only move the top section of the fiber, and only the movement of that top section produces the fringe. And we're looking at a linear graph here that shows the increase of fringe to velocity here. So the phase difference and the movement speed of the fiber is shown here with a linear proportional ratio to V over C, which is exactly what the classic ether theory predicts, and not what relativity predicts. Actually, relativity predicts the opposite. Like I said, it predicts no fringe pattern. It predicts that the split light beam traverses isotropically in all directions. And so as it traverses this, there's going to be no difference. And if it did predict a difference, it would predict a V over C squared ratio, which would be much smaller than what was measured here. So that's pretty damning in terms of Einstein's use of the same equations to describe an etherless paradigm when we have, motion being relative to the V over C, absolute ether frame for measurement there of velocity, which is supposed to be not possible. So it's supposed to be, against physics there. And again,
Damn.
this and Wang notes here, using several different configurations to his fiber, this motion is independent of the refraction index of the waveguide. So independent of the refraction index of the fiber itself, he used like a $50,000 military grade fiber optic gyro for this, that he took the spool out of. And he used an air core fiber for the conveyor. No, I'm sorry. The air core was for the gyro component as well for the light to traverse through. And then he also had an air conveyor where the detector would, basically glide with the relative motion of the moving portions of the conveyor here. And then, according to relativity, there should be no relative motion between them. But yet the first order fringe was measured, with a linear relationship. So independent of the refraction index. So no refractive medium being carried here. So the only saving grace for relativity at this point would be as if they had some magic mutually exclusive half gamma order term, and that completely defied all classic theory predictions. And that's exactly how this ends up being framed. So we enter 1938 with Herbert Ives and George Stillwell. Now, Ives and Stillwell are very accomplished experimentalists. They have really awesome track records, highly prominent lads in the lab. And Ives constructed this experiment to determine the frequency change of transverse motion for to substantiate Lamar's and Lorentz's theory on how there was going to be a frequency change to the term of that half order gamma. But keep in mind, relativity also uses the half order gamma term. So when you go through his paper, he's actually describing everything through the lens of confirming the change of frequency of the waves, not the contraction and dilation of reality of the wave itself. And the way that they would do it with, in the relativistic paradigm, because they would try to say that there's like a photon and that's being, contracted and all that kind of stuff. So the way that they have to look at it, no, I'm sorry, that the hydrogen atom that's going to be emitting the light in this scenario is experiencing time dilation, and its time dilation is being imposed on the frequency of light that it's emitting. And that's only possible due to this relativistic mechanism. And, that's the way that it's framed to look at. But the way that it was originally derived, of course, was just the frequency change of the wave itself with respect to the medium as a function of the medium imposing the physical mechanism of the retardation, rather than, physical nothingness and the dilation of relative time. So anyway, this apparatus here, we're gonna take a look at some top-down schematics of what we're looking at here. So we have a cathode ray that emits, that has hydrogen in it, and it's ionized hydrogen. So it starts off, very energetic and fast moving, but they're going to de-ionize it so that they strip it of its ionization. They send it through a chamber that has an electric field in it at different at different voltages, and at those different voltages, that's going to dictate the change in speed of the non-ionized hydrogen moving through the chamber. And then as the non-ionized hydrogen gets to the end of that chamber, there's an ionization chamber at the end of it. And the process of that reionization creates, it emits photons, it emits light. So their interpretation of photons, of course, is little quantized chunks of energy that are discrete packets. But of course, we're just talking about it emits radiation that has a certain wavelength and frequency to it. That's all that really means. But so anyway, that process emits light. And so now we have this really fast moving source emitter that's moving at, quote, relativistic speeds. It's moving much faster than anything that we could do terrestrially in the lab. So by using the frequency change of light emitted from this and using a mirror in here, he can measure the longitudinal and he can measure longitudinal recession or approaching changes, so redshift or blue shift changes based on the emission of the reionized atoms in here. And then they're going to hit a mirror on the outside of here that's going to reflect to a spectrometer, but based off of whether it hit a mirror inside of here is going to determine whether it's blue shift or red shift for its reading here. So here's just another diagram kind of showing this would be the ionized hydrogen re-emitting photons here, and the photon that's going to get the recession is going to be hitting a mirror here, and then it's going to travel back, so it's going to be carrying that recession velocity to it, and then the one that was receiving velocity addition is going to be blue shifted here, so that's going to be the one that just hits the mirror, then goes off to the spectrometer here. So this measurement was done in wavelengths of angstroms, which is a really, really, really tiny measurement. It's 1/1000th of a meter, or I'm sorry, 1/100000th of a nanometer. Really, really tiny here. But when they get down,
Alan, it's 1/10 of a nanometer, which is 10/1000th of a meter.
Oh, thank you, sir.
Sure thing.
So really tiny, precise measurement here, but still, small ratios of the same stuff that we're all familiar with, because most of the wavelengths that we're dealing with are in nanometers here. But now we're just up in the scale a little bit here in the angstroms, in the angstrom units instead of nanometers. But what we get out of that is really precise measurements and the ability to measure these really small changes that are supposed to come out of these theories when things are moving at these velocities. So here's just another diagram of the same thing, just kind of showing it over and over again. Here's what the cathode tube looked like. That was where the hydrogen, had to traverse through here, that was getting ionized. And then through the top down view here, we can see when it goes here, hits a grating, and then it goes into the photographic plate. So this is how they're doing their spectroscopic analysis, by splitting it to that grating, and then they're looking at the frequency changes in there to get the corresponding wavelengths. And then, based on whether or not the light came directly to the grating or hit the mirror on the back and then to the grating, is going to determine the red or blue shift mechanism. And what you see here is that he measured a linear relationship pretty much to the values that were predicted by the half-order gamma term. So as we have here, the voltages that were used, the type of hydrogen that was used for the ionization process. So these are going to produce different wavelengths for the emission and all that. That's why that's relative. So the manipulation of all these is going to, still produces ratios to that half-order gamma term. And this is what was observed here in angstroms. So we have this is the changed wavelength here that was measured as a half-order gamma term. And now keep in mind, he derived these under the principles of having the confirming Lamar's and Lorentz's theories about how the frequency of the light changes itself rather than, time dilation and link contraction. Because that theory had been, this is 1938, so relativity theory had already been put forward and, advanced and taught as fact by then. So he wasn't even mentioning any of that or trying to confirm that, but the equation is nonetheless the same. And then, so what ended up happening is in the mainstream, they gave this guy accolades and prizes for confirming relativity down to the angstrom unit wavelength, which is, extremely precise and small. So they've got this one-way time dilation thing where they've, confirmed relativity down to the angstrom length, which is absurd because the exact same ether theory from which all these equations were derived from predicts the exact same function as a mechanism of the wave interacting with the medium itself. And so I was going through a spreadsheet here. I was able to recover a screenshot of it, but I'm basically working on a calculator here, so we can go through different experiments and show the wavelength changes and kind of confirm, what was going on there and see what ended up happening. But yeah, when you go through, the half order gamma term ended up being what produced the it was actually being what was measured. So that was pretty interesting to see that term, and then to find out that exact term that was producing that prediction was came out in 1989 under the principles of a medium. So we have repeated experimental verification of the change in angle when you add a medium to the speed of light and a velocity component to the receiver. And we have tons of instances of interferometry. The basic principles of it operate on C plus or minus V, creating a real fringe pattern that's proportional to the wavelength changes, which change as a ratio of velocity to the speed of light with respect to an elastic medium. The principles on which everything was derived on, the original principles, have never changed. It's always been this. It's just been repackaged and redescribed as relativistic effects, although it's never not been this. It's always been this, always and forever.
Awesome. Such a needed elucidation of what actually happened, because the way they package it and what actually happened is very different. Like, look, relativity predicts everything. Like, well, the fundamental basis of wave theory on which it's based predicts everything, and then you remove that and said, actually, now relativity predicts everything. That's quite different than what you just said.
Yeah, it's insane. And what I forgot to include here or transfer over was was how Einstein derived the speed of light. So we're going to look at that real quick, because remember, if he was going to propose a new theory that says something physically different than the interpretation of the equations once we're already derived, then he's going to have to show, how he's deriving, how he's mathematically deriving his constants and axioms based off of his principles here, off of his postes, otherwise known as postulates, but we call them postes around here. So to start us off on his postulates, what I talked about earlier with the equivalence of inertial frames and the speed of light being propagated independent of any sort of velocity, and there will be no need for any introduction of a luminiferous ether. It'll prove to be superfluous, in as much here as the view developed will not require an absolutely stationary space provided with special properties. No, oops. How do I change this? Single page. There we go. It will not assign a velocity vector to a point in empty space in which electromagnetic processes take place. So in other words, no using V over C relationships, because that implies an absolute space. If you're going to use, if you're going to talk about speed of light and relative motion, you're going to have to use a gamma factor, and you're going to have to use Lorentz transformations, or at the very least tag on a gamma factor to make it relativistic. So that's what he's putting forward there, so that there's no use of the V over C relationship. And as we go down to him deriving the constancy of the speed of light, where's the section? Yes. Wasn't it this one? Hang on one second. Yeah, right here. So remember, speed of light independent of motion. He goes on to start deriving how the speed of light works in between an observer relative to a stationary reference frame, not to be confused with an ether or arbitrary mathematics stationary frame, defined as absolute, but definitely not that. But then anyway, he introduces relative motion here, c plus or minus v, to set a symmetrical midpoint so that the two-way speed of light is equal to the one-way speed of light. And in doing this, he doesn't independently derive the speed of light. He uses velocity to show that the speed of light is dependent on velocity, and in the way that he derived it. He postulates that it's, looking back here, that it's independent. Oops, where's this? Is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body or the receiver. Now, it doesn't say receiver in here, but he goes on in the paper to describe what happens to the moving receiver and the changes that go on with respect to that. But yeah, in his derivation there, it's entirely dependent on the motion of the two observers to set the symmetrical midpoint to them to define the and then he just says that an inertial frame is defined by being a uniform rectilinear motion. So instead of using the ether frame as the symmetrical midpoint and acknowledging that, he just uses the other reference frame. And because time and space have been conflated through the transformation that we looked at earlier, he defines coordinate time and proper time as arbitrary things that are defined as a function of relative velocity between two observers. But again, didn't show that the speed of light is independent of that. He actually made it completely dependent on it. So this whole thing is completely backwards and mystified and put into the public in such a way that you could never critique it. You could never understand it. You could never be smart enough to understand why there's a half-order gamma term here to describe the relative velocity between two observers, because there's no medium, guys. It's just time dilation.
So it's either C plus V, or it's C is constant, but time is dilating in the exact amount that the V would have shifted the speed of C.
Proportional to C. Yeah.
Yeah, that's retarded.
Exactly. That's exactly it.
And if you point that out, you don't get it. So
yeah, you must be wrong, yada yada. I mean, dude, think about that. You start off by saying it's if you were in the 5th grade and your teacher was like, hey, independently derive the speed of light, and you were like, okay. And
I'm gonna need that V real quick though. Can I have that V? No, I know it's independent of the V, but I need the V to do it. I know you don't get that.
So student A derives the speed of light under the inverse of the vacuum, the inverse of the square of the vacuum properties of electric and magnetic permeability, right? And that guy gets the speed of light. The other guy derives the speed of light independent of motion by using motion. Oops, you would fail immediately. You in any scenario, that's hey Timmy, you didn't
remember the
make
only
it.
criteria for the thing that we were doing? You remember that? Yeah. Well, you did that thing specifically, so you lose.
Yeah, none of this has ever been derived independently of a medium. And what Einstein just tried to show us there was, it's independent of motion. It was completely dependent on motion and setting the arbitrary midpoint so that the two-way speed is equal to the one-way speed.
Scientific trickery. All of this really stems from the Copernican principle, right? The steadfast philosophical belief that we're not at the center and not important. Therefore, when we fail to measure Earth's orbital motion, we're not wrong. It's just a no. It's just, no, we're still definitely moving no matter what we do or what we measure. We'll just gotta work in our empirical measurements into that paradigm.
You just can't tell that we're moving. There's not going to be any physical evidence that we're moving because we're moving.
Imagine coming to that conclusion via science. Listen, we'll never be able to measure it, but we know it's there.
Listen, we know that we're moving at 30 kilometers a second, so we know that there's no ether. And the same theories that we were using to predict weird second order effects that cancel out the motion are also how we know that we're in motion and that there's no medium. It's like, what did you just say to me?
Imagine that being your position and then being like, what are you, a science denier?
Yeah, that's why Einstein could never debate anyone. That's why it was always there was heavy censorship through when his theories were being put forward and promoted as fact, because without 100% control of the narrative, all of this stuff is just, it's ripe for the picking, man.
Dude, that's why all the somersaults and bending over backwards within GPS with the ECI frame, all to pretend that C is constant because it has to be for all eternity. That makes a lot more sense when you understand the significance of the constancy of C and why, when it's not constant and expressed and used as C plus V, then why that breaks relativity. Because they just say, nah, it's fine. Yeah, we need it. Look, we simultaneously need it to be constant and think that it's okay that it's never constant. Don't worry about it.
Dude, so check this out. Under what we just learned, how if you're not traveling at least 30,000 kilometers a second, relativity doesn't even enter your world. And the speed of light, in classic physics is the fallback for non-relativistic speeds. So we have the Earth moving at 30 kilometers a second. We have a zenith mount telescope. We know that when you add light, or when we add water to the telescope, the angle should be increased to 28 arc seconds. Now, Einstein's proof of correctness of his theory was that if you drop his velocity addition term, which gives you that hyperbolic curve, you'll get the Fresnel drag, which is the velocity of the medium dragging the light through it. So in other words, relativity to be consistent on the first order in the way that they would like it, they would actually predict that when you add water to the telescope, that the angle will change from 20 arc seconds to 28 point ... to the 16th decimal place in terms of angle change. And the classic theory just predicts 28 to whatever, a much smaller decimal place change, whatever you could get it to, but it wouldn't be to the tune of the square, right? That'd be ridiculous. But mechanistically and logically, if you were to follow it through in the way that they put it forward, the fact that they put water in the telescope and it didn't go to 28, I mean, that's game over on the face of it, dude. The fact that they ignore that one and then try to go, oh yeah, but if we assume the velocity on the back end and transform to position on the sun, we can describe why we can't see it in our frame. It's like, dude, just, you played yourself, player, as DJ Khaled used to say.
Just stop gaslighting your own soul.
Well, that was a detail-packed 2 hours, my man. Have a peek at the chat. Is there anybody up with a question?
Yeah, I'm taking a Gandy over here.
There.
I'm not seeing any direct highlights or anything. So we got some comments on transverse drag and retarded in the other direction. Sounds like a political campaign. Dude, you can only get away with saying retarded in physics for now. For now. No, I'm not seeing much.
Got that motion good and retarded, did you?
Mm-hmm. But yeah, well, thanks everyone for tuning in. It was an information packed 2 hours to go over the whole history of everything, but now we know mechanistically that we don't live in an etherless paradigm, or at least that there's a lot of evidence that that there is some sort of medium mechanism that's facilitating the frequency and wavelength change proportional to all velocity relative to said medium, as how it would function demonstrably with sonar and range measurement equations. These basic fundamental principles wouldn't work if there was no said medium for which everything was a medium for everything to be derived from. Tongue twister.
Once was derived.
And
from which was.
And the measurements that they're taking have a sidereal periodicity to them, not solar.
Ooh, dude.
For me, the effort to hide all this though is like the biggest part. Like just like if it was the way that we're saying, why all the effort to hide it and pretend that it's not, and to steal the same equation and then pretend that you didn't, and then tell everyone that it's different, but have no actual backup for it. Like, why would you do all that if it wasn't exactly this?
Yep. But yeah, all right. So we'll be live again on Monday on my channel for Celestial Theodolite number 20 thrice. We'll be going over the eclipse video that our boy Brian just put forward, measuring the altitude of the, or rather calculating the altitude of the sun by the occlusion timings using the path length of the shadow of the sun and the altitude of the moon. So it'll be very cool to see what happens with that when we put that forward on EA on Monday. And then Tuesday, of course, will be Roundtable 106, where I'll be doing a presentation most likely on what Stone was just touching on about the sidereal effects that were measured through interferometry that continued after Michelson-Morley by Dayton Miller, Hector Minera, Kennedy and Thorndike. There were a number of interferometric experiments that were conducted, so we'll be going over some of those, but primarily we'll be going over the papers of Shankland and Robert Thomas, who say that they can explain the anisotropic measurements in the Michelson-Morley apparatuses that Dayton Miller took continuous measurements on, and showed that there was a sidereal fluctuation, and on the equinoxes there was a minimum and maximum dimension. So there is a solar effect, an annual solar periodicity that's measured, but it is nowhere near the tune of the 30 kilometers a second. It only reaches a magnitude of about 8 to 10 kilometers a second, and scales with altitude, which is another, like, dude, if the speed of light is constant, if it is a physical constant, but it scales measurably at altitude, like, that's game over for them. That's insane.
And we can thank
yeah.
and we can thank Shankland for burning all of the disruptive data.
Dude, it's such a shame, because when we read his paper, the grounds on which he destroyed everything under is absurd. It was a real uh, uh, crime to science, scientific fraud, actual fraud. But yeah, so we'll get into that on Tuesday. And then Friday will be the Twitter community space. So tune into that for Friday Twitter shenanigans that we'll get up to. And then I think Stone said there's going to be a new Telegram series where they're going to be discussing the world of finance on his Telegram. That'll be a weekly thing, you said?
Yeah, I think it might turn into a Sunday night thing. If enough people respond in the next couple of hours that they're going to come, I would even start tonight at a later hour. And it's not necessarily talking about finance, but more the paradigm of the monetary system as a whole, and what the options are, that kind of thing.
Awesome.
Nice.
Sounds fantastic, dude. Dude's ready to start up a gang. Like, just give me the lads and we'll figure it out.
Nice. Excellent prez, dude.
Thank you, sir. All right. Well,